Hi everyone, I am Mallikarjuna, working as an assistant professor in Laxman Institute of Technology and Management. Today we discussing about discrete mathematics in first unit mathematical logics. So in that topics are equivalence of formula and laws of logics. The first topic is equivalence of formula. Then what is the equivalence of formula? Two logical formulas are logically equivalent if they have the same truth value for every possible combination of truth values of their variables. It is denoted by P equivalence Q or P equivalence Q. So there are two methods for prove equivalence. So first one is by using truth table. And second one is without using truth table. These are the two methods for solving equivalence of formula. So here we solve the first problem by using the truth table. So here P exclusive or Q equivalence P or Q and negation P or negation Q. So here what is the equivalence of formula? So two logical formulas are logically equivalent if they have same truth value for every possible combination of truth values. So here we LHS side is P exclusive or Q equivalence P or Q and negation P or negation Q. So before that, what is the exclusive or what is the conjunction, what is the disjunction, what is the implication, what is the by implication? So we are know about that. First we consider the let P and Q are two statements. Let P and Q are two statements are two propositions. So here what are the truth values for P two variables? There are 2 power n cases, that is 2 power 2 equal to 4 cases. So true, true, false, false, true, false, true, false. So first one is conjunction P and Q. So if in P and Q, if both the cases are true, it will be true. Remaining cases are false. True, false, false, false. Disjunction P or Q. If both the cases are false, it will be false. Remaining cases are true. False. Here false. Remaining are true. Then P implies Q. It is the implication. So here first case is true, second case is false. It will be false. Remaining cases are true. Here first case is true, second case is true. Here first case is true, second case is false. So here false. Remaining are false, true, true. False, false, true. Next one is P by implication Q. If both the cases are either true or false, it will be true. Remaining cases are false. Here true, true, true. True, false, false. False, true, false. False, false, true. And P exclusive or Q. If any case, if first case is true, second case is false, and first case is false, second case is true, it will be true. Remaining are false. If true, true, false, 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 it is the exclusive or. So here false, true, true, false. This is the exclusive or conditions. These are about our basics of logics. So here given P exclusive or equivalence P or Q and negation P or negation Q. So draw the truth table for given logical equations, both LHS and RHS. Then we prove the RHS equals to LHS. So first take the two proposition P and Q. We observe what are the prepositions. We have two types of preposition. First one is P and second one is Q. So here two cases, true proposition. Then we have four cases: true, true, false, false, true, false, true, false. Then here P exclusive or Q. Then P or Q. Then negation P or negation Q. Then P or Q and negation P or negation Q. So if both the cases are same, so it is false. Here first case is true, second case is false. It is false. It is true. First case is false, second case is true. It is true. False, false, false. P or Q. If both the cases are false, it will be false. Remaining cases are true. Here false. True, true, true. Negation P or negation Q. So here negation P means it is false, false, true, true. Negation Q means false, true, false, true. So here it is false and false, true, 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 false, true, 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 false. Then P or Q and negation P or negation Q. What is the condition here? And means if both the cases are true, it will be true. Remaining cases are false. So true, false, true, false, false, true, 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 false, false, false. So here P exclusive or Q. So we observe that P exclusive or Q, equivalence P or Q and negation P or negation Q have both logically equivalence. False, true, true, false, false, true, true, false. So we say that P exclusive or Q equivalence P or Q and negation P or negation Q. So we prove that LHS equals to RHS. LHS equals to RHS. So simply we can understand this. Next problem, that is second example. So we take the LHS side and RHS side are logically equivalence. So here we have three propositions, that is P, Q, R. Next one is what are the given? Q and R. P implies Q, P implies R, and P implies Q and R, P implies Q, and P implies R. So we have three propositions. We get the 2 to the power of 3 cases, that is 8 cases. Here true, 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 false, 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 true, true, false, false, true, true, false, false, true, false, true, false, true, false, true, false. Next Q and R. Here what is the conjunction Q and R? If both the cases are true, it will be true. Remaining cases are false. Here consider Q and R. Here true, 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 false, 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 true, false, 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 true, 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 false, 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 true, false, 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 false. Then P implies Q. Here, what is the P implies Q? It is the by implication condition. By implication condition, if first case is true, second case is false, it will be false. It will be false. Here we consider P and Q. True, true, true. True, true, true. True, false, false. True, false, false. False, true, true. False, true, true. False, false, true. False, false, true. Next one is P implies R. P implies R. So same condition. P implies R. True, true, true. True, false, false. True, true, true. True, false, false. False, true, true. False, false, true. False, true, true. False, false, true. Next, P implies Q and R. P implies Q and R. So here first we start P. P implies Q and R. What is the condition? Implication. If first case is true, second case is false, it will be false. Remaining cases are true. True, true. True. True, false. False. True, false. False. True, false. False. False, true. True. False, false. True. False, true. True. False, false, true. Next one is P implies Q and P implies R. P implies Q and P implies R. This is P implies Q and this is P implies R. So what is the condition? And means disjunction, conjunction. True, true, true. True, false, false. False, true, false. False, false, false. True, true, true. True, true, true. True, true, true. True, true, true. So here LHS, what is LHS? P implies Q and R equivalence to P implies Q and P implies R. So here LHS equals to RHS. Both logically equivalence. So second method is logical laws of logics. So we have some laws. First one is identity law. So what is the identity law? P and T equivalence P and P or F equivalence P. So how it is possible? So here we take the LHS P and T. So we write the cases for P and T. Here P is true, false, and T means universal truth. So what is the condition? P and T. P and T means if both the cases are true, it will be true. Remaining cases are true. Remaining cases are false. True, false. So again we have P. That is P and T equivalence P. So LHS equals to RHS. So we write the P and T equivalence to P and also PRF equivalence to P. That is identity law. Next one, domination law. If PRT equivalence to T, so how can get the T? So here we have two cases, P and T. So P get two cases, true, false, and T, true, true. P or T, true, 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 false, true, true. So we get the LHS equals to true, true. So we can write the P or T equivalence true. So why are using domination law? P or T equivalence T. P and F equivalence to F. Next, idempotent law, that is P or P equivalence to P and P and P equivalence to P. Double negation, negation of negation P equivalence to P. Commutative law, if P or Q equivalence to Q or P, and the second formula is Q and P equivalence to P and Q. P and Q. And associative law, it is also called as same symbol law. So here we have P or Q or R equivalence to, we can write the P or Q or R. And distributive law, next one is distributive law. P and Q or R equivalence to, here we can write this LHS P and Q. So it is P and Q or P and R. P and R. Next, De Morgan's law. It is also called as negation removing law. So negation of P or Q equivalence to negation P and negation Q, and negation P and Q equivalence to negation P or negation Q. Next, absorption law. Next law is absorption law. Here P or P and Q equivalence to P, and P and P are equivalence to P. That is the absorption law. Next, implication law. It is most important law, that is P implies Q equivalence to negation P or Q. And contrapositive law, that is P implies Q equivalence to negation Q implies negation P. And by implication law, P by implication Q equivalence to P implies Q and Q implies P. These are the laws for in laws of logics. Then we can solve the, by using these laws, some problems. So here prove that P implies Q implies R equivalence to P and Q implies R. Take the LHS and prove the RHS by using the without truth table or logical laws. So I take LHS. P implies Q implies R. So here what is the condition? P implies Q implies R. What is the implication? That is implication law. What is the implication law? P implies Q equivalence to negation P or Q. Negation P or Q. By using implication law, so here we can write the P implies negation Q or R. This is P, this is Q. So we can apply the implication law. So what is the P? P means Q. So we can write the negation Q or R. Then again apply implication law. P implies Q equivalence to negation P or Q. So it is P. And we consider this one is Q. That is P implies Q. This is P, this is Q. So we apply the implication law. So negation P or negation Q or R. So here we observe that we have same symbols, that is R, R. So we use the associative law, same symbol law, that is P R Q R R equivalence to P R Q R R. Then that is associative law. So here apply associative law. Negation P or negation Q or R. So here we observe that negation P or negation Q or R. Here apply that De Morgan's law. Here it is this case having negations. So by applying De Morgan's law, negation P or negation Q equivalents to negation of P and Q. Negation of P and Q. So here we apply the De Morgan's law. Negation of P and Q are R. Then here it is we consider negation of P and Q as P and R is Q. So negation P R Q, negation P R Q written as P implies Q. Apply the implication law. Apply implication law. So negation P R Q equivalents to P implies Q. So what is the P is the negation P and Q. What is the Q? Q is the R. So P and Q implies R. So we prove that LHS equivalents to RHS. That is P implies Q implies R equivalents to P and Q implies R. Next, second example. So by using the second example, prove that P implies Q and R equivalents P implies Q and P implies R. So we take LHS side. P implies Q and R. So we have what are the symbols? Implication and conjunction. So by using the implication law, what is the implication law? Implication law, P implies Q equivalents to negation P or Q. Negation P or Q. So apply here that it is P, it is Q. P implies Q. Here P implies Q. What is the P? P is the P. Negation P or what is the symbol? R. And Q and R. Q and R. So here we observe that negation P, R, Q and R. So we observe that it is distributive law. What is the distributive law? Distributive law. P, R, Q and R equivalents to P, R, Q and P, R, R. So we apply the distributive law. Here it is negation P is the P. Here Q is the Q. Here R is the R. R is the R. So we form the distributive law. Here negation, what is the P? P is the negation P. And what is the symbol? R. What is the Q? Q is the Q. Then and P is negation P. R. What is the R? R is the R. So we observe the negation P R Q and negation P R Q. So it is implication law. It is implication law. What is the implication law? Negation P or Q equivalents to P implies Q. Here negation P is the P. Q is the Q. Here negation P is the P. here R is the Q. So what is the equation? P implies Q. P implies Q and P implies R. P implies R. So we prove that LHS equivalence to RHS. That is P implies Q and R equivalence to P implies Q and P implies R. Next problem. It is very important problem. Prove that P and Q implies PRQ is a tautology. Prove that P and Q implies PRQ is a tautology. So here P and Q implies PRQ. So here implication law. By using the implication law, P implies Q equivalence to negation PRQ. Negation PRQ. So P and Q, take it P. PRQ, take it Q. So here what is the P? P and Q. That is negation P. Negation of P and Q. Next R. What is the Q? Q is the PRQ. PRQ. Then apply the negation of P and Q. Apply the De Morgan's law. Apply the De Morgan's law. That is negation of P and Q equivalence to negation PR, negation Q. So here negation PR, negation Q or PRQ. So here we have same symbol. So we use the associative law. What is the associative law? It is same symbol law. P of PRQ Q R equivalence to PRQ R. So we use the associative law and we apply the commutative law also. What is the commutative law? PRQ equivalence to QRP. So negation PRP or negation QRP. Then we use the, what is the formula? Negation PRP equivalence to true. Negation QRQ equivalence to true. So what is the law? So it is the negation law. It is negation law. What is the negation law? Negation PRP equivalence to true. Negation QRQ equivalence to true. So here PRP equivalence to true or negation QRQ equivalence to true. True or true equivalence to true. So given logical equation prove as tautology. Next, fourth example is P implies Q implies P. Prove that P implies Q implies P is a tautology. So here what are the conditions? Implication. Both are implications. So use the implication law. What is the implication law? P implies Q equivalence to negation P or Q. So we apply in parenthesis. P implies negation Q or P, and again apply implication law. Negation P or negation Q or P. So we are using the commutative law. negation P are commutative law and associative law. Associative law, same symbol law, that is same symbol law. Here negation P or P or negation Q. Negation P or P by using the negation law. By using the negation law, what is the negation law? P negation P or P equivalence to true, that is true or negation Q. Then T or negation Q also true. So given logical equation is tautology. P or Q implies P, P implies Q implies P is tautology. Is a tautology. Next, fifth problem, that is negation P and negation Q and R, or Q and R, or P and R equivalence to R. So here negation P and negation Q and R, or Q and R, or P and R. So observe the given problem. Here negation P and negation Q and R. Here it is having same symbol. So we can write as by using the associative law. By using the associative law. What is the associative law? P R Q R, R equivalence to P R Q R R, and P and Q and R equivalence to P and Q and R. So here we can write negation P and negation Q by using associative law and R. Here we observe that Q and R are P and R. Here R is common, that is we can take as P, and Q is P and R is Q. We can apply the distributive law. So here R and P R Q. This is the equation. Then here apply the De Morgan's law. So it is negation removing law. Here we apply negation of P R Q and R, and R and P R Q. Again we observe that R is common. R. It is taken as P. P R Q, negation P R Q. It is Q. It is R. So R and P R Q are negation of P R Q. R and P R Q are negation P R Q. That is by using negation law, P R negation P equivalence to true. So it is P, it is negation P. So here true. Then R and T equivalence to R by using the, what is the equation? By using identity law. by using identity law R and T equivalence to R. So we prove that LHS equals to RH. So we learning equivalence of formula and laws of logics. In that equivalence of formula, what is the equivalence formula? Two logical formulas are logically equivalent. So it is denoted by P equivalence to Q, and it is we have two methods to solving equivalence of formula, using truth table. Second one is without using truth table. So these are the laws of logics. First one is identity law, domination law, idempotent law, double negation law, commutative law, associative law, distributive law, De Morgan's law, absorption law, implication law, contrapositive law, and biconditional law. So by using these laws we solve the without using truth table.